Hi, my name is James Duncan. I'm a Ph.D. student at the National Wind Institute studying wind energy. So my current research is focused on the development of smart wind plants. One of the preeminent challenges facing the wind energy industry today is that of wind plant underperformance versus pre-construction estimates. Now what I mean by that is that when we develop a wind farm and put it out, we have an expected power output that we hope to get from the wind farm. However, a lot of the deployments, we see that the wind plant actually doesn't produce as much as we would hope. And so one of the preeminent research focuses within the industry currently is trying to mitigate this. And there's two causes to this. One is that power production as a whole is focused on optimizing power from each individual turbine rather than looking at the wind farm as a whole. Now when we start looking at the wind farm as a whole and trying to optimize that, the next problem is being able to understand the complex flows that are within wind farms. And so the models that go into optimizing these wind farms, they're unable to adequately quantify and understand the flows currently that are existent. So here at Texas Tech, we've been able to use the mobile Doppler radar systems to actually go out to wind farms and be able to document and record and characterize the three-dimensional flow fields that are passing through wind farms, and note how turbines are interacting with one another, how the presence of the turbine impacts the wind field, and how that impacts the potential power output downstream. Now, as a research focus, the goal of this is to look on how to potentially minimize the negative effects of turbine-to-turbine interaction, which would improve the power production on a net whole, and additionally look to improve individual turbine power output by supplying knowledge of the upstream flow into the control strategies of the turbine. Now by doing this, we can hopefully be able to optimize and take the wind energy industry to the next level, and as we know, that will definitely help with greenhouse gas emissions and other things that are negatively impacting the climate.